Hello, everybody, and welcome to our ARC webcast. I have in the studio today two industry colleagues. I have Christian Müller from Audi and Oliver Narr from Siemens, and we're here to talk about the project EC4P at Audi. EC4P stands for Edge Cloud for Production, and it's a pioneering project, an initiative that has been going on since 2018 at the company, and it is probably the most interesting, most compelling lighthouse project in the area of IT, OT convergence in industry. It's really fascinating work being done at Audi. I want to introduce and ask a couple questions, first of all, to Christian from Audi. Christian, could you briefly introduce yourself and just tell us what you do at Audi?
Hi everyone, my name is Christian Müller. I work with Audi in Ingolstadt, and at the moment I'm responsible for the development team for this EC4P project. Me and my colleagues, in total 13 people, are trying to improve the EC4P architecture and put a lot of effort in transforming the legacy applications that they will run smoothly on our new platform.
Tell us a little bit about EC4P. I know that you've been working on it for about going on 8 years now. In fact, your colleague Henning Löser described it for the first time in a presentation at my company's forum in 2020 at the industry forum in Orlando. But in the meantime, you've come a long way. You've made a lot of progress. What is the essence of EC4P? What does it do?
That's a good question, David. So when we started in 2018, we were part of the so-called Audi Production Lab, where Henning Löser is the head of. And within this production lab, we had the freedom to dig into new technologies. And there, the idea of the EC4P project was born. In that time, the Windows 10 upgrade was coming in, and we had a lot of resources going outside to buy new industrial PCs to make that change. And therefore, we had that one question: why do we have so many industrial PCs in our shop floor? I would say in total roughly 10 to 15,000 in Ingolstadt and Neckarsulm, and why don't we use common data center technology like virtualization to get rid of all these industrial PCs? And then we did some first tryouts, we did some research, and we had that one goal to have one centralized platform running all our shop floor applications. And to fulfill that need, we also talked to a lot of colleagues within Audi, within the industry, and we also had in mind, why do we have physical PLCs? So our goal was, hey, when we build a new platform, that should also be capable of running PLCs and also safety certified PLCs. And it was the early beginning of the project. And then for the next 2 years, we did a lot of research. We had, I would say, in total 10 to 15 bachelor and master students doing their final thesis on this topic. We have 2 PhD students doing their PhD on that topic. And after all that research, we come to the point, yeah, technically it would be possible to run even a PLC on a platform. But then we had the issue with, hey, okay, technically, it will work, but there are no products on the market. And then we teamed up with 3 companies. One of them is with me here today, Siemens. We also teamed up with Cisco and VMware, now Broadcom.
You didn't just start taking IPCs off the floor and putting software elsewhere. You actually developed an architecture, including some pretty sophisticated networking technologies from Cisco. Can you describe the reference architecture?
To run a PLC in a data center, you need 3 puzzle pieces. One puzzle piece is the networking. So you have to bring all the field bus communication from your robot cell to the data center. Therefore, normal enterprise network is not capable of running something like Profinet. Therefore, we teamed up with Cisco. We developed a reference architecture with them to tunnel Profinet real-time network over a layer 3 enterprise network. So that was the one puzzle piece. The second puzzle piece was if you want to run a deterministic workload like an PLC on a virtualized environment, that virtualized environment need to fulfill the real-time requirements of an PLC. Therefore, in the hypervisor of the visualization platform, you need a lot of optimization to fulfill the real-time and the deterministic behavior requirements of the PLC. Therefore, we teamed up with VMware, and they helped us to optimize their visualization stack to fulfill that requirements. And the third puzzle piece you need to run a visualized PLC is you need a visualized PLC. And therefore, Siemens, as a big, well-known company for the VW group when it comes to automation technology, we teamed up with them to drive our architecture that way that they can provide us their new visualized PLC. And then only with the joint effort of all the three companies, we can fulfill the requirement and the final goal of running visualized PLC workloads in the data center.
As part of this project at the beginning, I remember the presentation from Henning back in 2020, right before the pandemic started. He announced a new automation paradigm, and I was fascinated by this. I actually borrowed it, and I've used it many times in presentations myself to show the concrete, practical side of implementing Industry 4.0 or showing evidence of the IT-OT convergence. Let me just share right now a slide from Audi that shows the paradigm. Can you explain it? If I need a special function, I buy a box.
Maybe I'll start with a well-known example. In the old days, you bought an MP3 player, you bought a notepad, you bought, I don't know, a calculator. Nowadays, you have your smartphone and you buy apps like software. When you shift that paradigm to the shop floor, nowadays, if you want to have a new feature, you normally go to your supplier and he will sell you some box. On that box runs the software, but it's all proprietary hardware and software. You can't run it elsewhere. And we would like to change it. So we set up that platform that can run deterministic workloads. So now we can buy that proprietary stuff, not off the shelf like hardware. We buy it off the shelf, but in software. And that brings us to a lot of new features. So in a complete life cycle of a body shop, and we are talking about 8 to 10 years, at the moment it's nearly impossible to bring in sophisticated new software features because the proprietary hardware was not built for that. If you buy software, you can update it, you can bring in new resources quite easily, and that's something it will become very important now and also in the future. We're also talking about new workloads like AI and stuff like that.
All right, let's turn to Oliver Narr from Siemens. Oliver, you and I have known each other for a long time, but could you please just say a couple of words about yourself, introduce yourself to the audience?
Yeah, hello to everyone out there. So my name is Oliver Narr. I'm with Siemens and responsible as a chief product owner for several products of the Simatic PLC. One of those products is the virtual PLC. And I had different stations within Siemens in development, sales, product management, etc. And the last years, I was responsible for driving forward to make the first virtual PLC available from Siemens.
Oliver, EC4P is all about virtualizing shop floor software and getting rid of legacy hardware. I'm a PLC guy. I like to think of the PLC as the center of everything, the heart of the shop floor. And yet Audi first went after the non-time critical software, saving the hard stuff, the real-time PLC for later. Tell me, is the industrial world even ready for a virtual PLC?
Yeah, for me, right now, we are at a turning point, right? So, I mean, going from hardware-defined to more software-defined automation. And I guess the approach from EC4P colleagues was really, I mean, the best one you can do. You take the non-time critical apps, you learn with that, and you go for the critical timing applications, which is the real PLC, later on, right? So I guess this is the best practice pattern from my perspective to shape the industry, and the colleagues from Audi with EC4P, they just did it. And technically that does not mean that, I mean, we all know those boxes, right? Hardware-based automation, I mean, those things will stay. But now there's definitely the room for certain applications also to switch to pure software-based approaches.
When I think of a classic PLC, it carries its own hardware. It's in the same way that a snail carries its shell as it walks along the beach. It has everything with it that it needs to survive. When you unbox a PLC, you take it out of the box and you have its performance in your hands. When you unbox a virtual PLC, which is impossible because it's just a license, but when you implement the virtual PLC, the performance is no longer depending on the product you just licensed, but on the hardware you're installing it onto. And you at Siemens, you say, customer, you have your free choice of hardware that you want to use. You never made an attempt to bundle it, for example, with a Siemens IPC just to guarantee a certain performance level. So how much of a risk is that for Siemens, and how do you manage customer expectations of performance?
I mean, for sure, it's a different approach, but I wouldn't call it really a risk. It's more an opportunity, because at the end, most classic PLCs, I mean, there's a good reason for that. But if you want to go for the virtual one in more an IT environment, because there are good reasons for that. Running a PLC as a software service, and not talking about just one, two, but hundreds. And you are right, those hundreds of PLCs will be run on generic hardware. So this brings some changes to how to operate those things. So especially when it comes, what are the capabilities at the end? We talk about the real-time capabilities. And there are certain things we did different in comparison to the hardware ones now with the virtual approach. So first thing is we have a reference platform in place. So that means we're telling the world, okay, if you're using a hardware which that and that capabilities, you can expect that and that runtime behavior, for example. What we're also doing, we're validating those stuff with different kind of variations internally, also together with key customers. For example, Audi is one of those. So this is what we're doing additionally. And furthermore, we're bringing new diagnostic capabilities to the PLC to monitor not just during the commissioning phase, but definitely also during operations. What is the situation? What is the health factor of my environment here? So these are the different things. And this is for sure a change, but nevertheless, the big benefit we are making the PLC a software service. Not just for one instance, but for multiple one, which is increasing rollout, update, security concerns much better in comparison to the boxes, and at the end scaling and be flexible in this volatile world is definitely a game changer for certain production lines we see today.
I understand you have not just a virtual PLC, but a virtual safety PLC, or a safety virtual PLC, whichever you want to call it. I want to ask you about the certification process for even making that happen. But first, can you tell us the functions? How is this currently being used at Audi? What are the safety functions being monitored, or what is the application?
Yeah, so when it comes to typical safety applications, I mean, the big standard case is automating robot cells with a safety PLC for controlling. So that means the robot cell where critical elements are produced, like the bodies of the car. And those things are critical for humans. They can harm them. So this is definitely a safety application. For sure, there are other ones like AGVs, for example, or standard assembly functions. But these are, I guess, the most famous ones. And at the end, some years ago, a lot of people said this can never be happened, right? And from our perspective, we just did it. Right? For sure, there was something additional work needed, but today, a TÜV certified virtual PLC for SEAL Level 3 is available for productive use, and you see it already running since months at the Audi facilities, and really doing the big change in the industry, not just for standard automation, but also for safety certified automation. It was not for free, for sure, right? So we had to do some things for that. I mean, you asked me what was the process all about. At the end, the big benefit is the basic pattern didn't change. So we are using since years, so with a very mature software stack, the coded processing principle. So that means there is no redundant hardware needed for safety, but we do it in software. That means at the end, do things twice and do it a little bit different, right? But in software. And we could directly apply this principle also for the virtual world already in the engineering part of the process. And that means at the end, you will get the same behavior as if you would have a phase F version of the physical one, right? Which is a big game changer for compatibility, for switching to virtual and hardware between those two instances, for example. So it's basically the same. Also for the safety approach. That means at the end, is everything the same? Not completely. There are some small things to consider if you run it in the virtual world with safety. For example, when it comes to a second timer, because timing is essential for safety verification. Today in the hardware world, you get the timing from the silicon, right? In the virtual world, you have to make sure your architecture is right, that you have always the right timing, usually from two sources. And here, I mean, if you're a customer, if you want to go for safety, my message is you can do it as you did it with the hardware PLC. But for example, you need a PTP timing compatible network card according to IEEE 1588 standard. So the IEEE standard is here the thing you have to consider when it comes to network cards. And if you want to go the same approach as Audi did with virtualization, you also have to make sure, okay, the virtualization layer also supports this conformance. But this is basically the big difference in comparison to the hardware world, right? So conclusion is you can go on, but you have to make sure when it comes to timing, do you have the right network card in place where we can get a second timing source? And if you want to use also virtualization and not run it on bare metal generic hardware, also the virtualization layer needs to be considered. But everything else is from the certification process. As you get it from the hardware world, it's a TÜV certified product, and you can use it like that.
All right, thanks, Oliver. I find that the safety aspect of it really fascinating, going right from virtual to the next logical step, having it safety certified. Back to Christian, when you at Audi first approached Siemens about supplying a virtual PLC, this technology was new even for Siemens. Can you describe for us the cooperation with the Siemens engineers? Did they just supply a license for the virtual PLC, or did they contribute to the engineering together with Audi and maybe even together with the other vendors?
So it was also for Siemens a long journey with us. So I think we started to talk to Siemens 2019. First we went to the Hannover fair, talked to Siemens, told them, hey, we would like to buy your PLC, but not in hardware. And I would say there were not a lot of people within Siemens. They thought that would be a good idea. But we found some colleagues at Siemens, they supported us, and we did some first testing, some first proof of concepts with the old PLC, but compiled in a virtualized environment. And the first proof of concepts were such a success that also the mindset within Siemens changed. They also said, hey, yeah, in the end, software is the thing we want to sell in the future. And I would say starting 2020, the whole project got a big boost. So within Siemens, they built their own organization around that topic, and we, I would say, worked together really closely. It was like one team driving that idea to the first product without safety. We built our first cars with that non-safe PLC, and then last year, roughly around 1 year ago, we brought the first virtualized PLC with safety in our production, and since then we are building cars with that technology, and I think that's quite a good success story. So we teamed really up. We ramped up our teams. Siemens ramped up their teams, and I would say it's a completely joint innovation that we had there together. And also with the other partners, we set up a test bed in the US where we did a lot of end-to-end testing, because as I mentioned earlier, it's always the three puzzle pieces that need to work together to fulfill the requirements what we have with the real time and with the safety. And I think that works extremely well. And and I would say let's go further together.
And I think it's really amazing to see what can be done if the right players come together, right? The last 6 years now. And I guess we really shifted the frontier, what is possible. What should always be considered is shifting that frontier, that work is already done, right? So the products are available now, to go those things, and it will definitely not take additional 6 years to bring today an environment to this virtualization approach, right? So a lot of appreciation also from Siemens side towards Audi, right? To go that journey, to drive that forward, and really acting here as a pioneer to make this happen, to make today's portfolio landscape not just a hardware landscape, but also a software landscape when it comes to PLCs.
All right, fascinating stuff. Let's wrap it up. I just got a final question. Where does it go from here? You've come so far in testing in production. Is there a big rollout scheduled for the concept of EC4P for the reference architecture? Maybe Christian, you can start and let us know what we can expect.
Yeah, so maybe let's start a little bit in the past. So we started in the Böllinger Höfe. That's our smallest plant where we built the e-tron GT, where we did the first testing and had the first go lives. Now we are scaling to our big two plants in Ingolstadt and Neckarsulm, where we're doing some retrofit with the VPLC, and all the new body shops we will set up will be powered by the VPLC. So it's also for us the overall strategic goal to bring in every plant the EC4P platform, and also bringing VPLCs to every body shop we are setting up. And therefore we are now scaling up to Mexico. We are planning the new car in Ingolstadt with the VPLCs. And I think it's, at least for Audi, it is the way to go, running everything on a centralized platform. And also what we see in the future, more and more process device vendors are coming to us and say, hey, now we have your edge cloud. May you want to buy our controllers and stuff like we deliver to you as a hardware box now on software. I would say that's the ecosystem will also drive that way, and I think that's one big success for us.
All right. Well, as I said at the beginning, this is pioneering work. I think the rest of industry, not just the automotive industry, but all different segments of industry will profit from the work that was pioneered by Audi, by Siemens, and also by the other two partners, Cisco and Broadcom. Excellent work, guys.
Thank you.
Thank you to my two panel participants today, to Christian Müller from Audi, thanks for your time, and to Oliver Narr from Siemens, thanks very much. And to my audience, we look forward to seeing you in the next webinar. This, by the way, is a series of 3 webinars. We'll be holding a similar conversation with Cisco and another conversation with Broadcom coming soon. Thanks for tuning in, and see you soon.